In this section, we're going to be working with absolute values in terms of solving equations and inequalities. The first thing to remember when we're working with absolute value is what an absolute value is, and then to always keep in mind that we're working with cases. So to get started, when we're talking about the absolute value of x, this basically means how far is this from 0. It doesn't talk about direction. It doesn't talk about it whether it's above 0 to the right or below 0 to the left. It just means how far from 0. So if we take the absolute value of a negative 2, how far is negative 2 from 0? Well, here's 0, here's negative 1, negative 2, so we can see that it's 2 units. So the absolute value of negative 2 is a positive 2. Again, I don't care about the direction that it's to the left of 0, I just care about how far it is from 0. So the absolute value of a negative number is always the positive of that value. We could also look at the absolute value of 3. So this is asking how far is 3 from 0. And we can see from what we have drawn here that it's 3 units. Now it doesn't matter that it's above or below, it's just 3 units. So I have my value of 3 here. Well, a lot of times we're going to be asked to solve for a variable in these types of problems. So you might be given the absolute value of x equals, let's say, 6. So this basically means what number is 6 units from 0? Well, we know that x could either be a positive 6 or x could be a negative 6 then, because that could be 6 units above or 6 units below. So when you're solving these and you just have a variable, they're pretty straightforward to do. But sometimes we actually have an equation involved. For instance, the absolute value of x minus 3 equals 4. Now you can solve these with graphing as well, and I'll show you how to do that in a minute. What we need to remember here is we have cases. Up above, when I talk about my cases, I have the positive and the negative case. So you have the positive and the negative. Here I have cases as well. I have a positive 4 case and a negative 4 case. So I write out my two cases. X minus 3 equals negative 4 and x minus 3 equals positive 4. So for my first case, you basically just drop the absolute values. For the second case, you drop the absolute values and negate the right-hand side. So I solve each of these. I add 3 to both sides. Here I get x is equal to negative 4 plus 3 is negative 1. Over here, I'll add 3 to both sides, and I get x equals 7. Now let's go ahead and check this. If we plug a negative 1 in up here, negative 1 minus 3 is negative 4. The absolute value of negative 4 is positive 4, so that works. Over here, if I plug in a 7, 7 minus 3 is 4. The absolute value of 4 is 4, so it checks. But I also want to graph these. Now when you graph an absolute value, just as we have before, you need to make sure that it's been set equal to 0. So when we graph this, we'll graph the absolute value of x minus 3 minus 4 equals 0. Now notice the minus 4 is not part of the absolute value. So this is what we'll graph. Now some of your calculators will not say absolute value vertical bars, they'll use ABS. So let's go ahead and see how that looks. The absolute value can be found under math, and then scroll across to number, and it's the first one listed here, absolute value. Now mine has the vertical bars, yours might have ABS and then open parentheses. So the problem we had was the absolute value of x minus 3 equals 4. Now you have to close the parenthesis here if you're using the ABS, or make sure you're outside of the parenthesis when we subtract that 4 over. I'll go ahead and hit graph. So it looks like we're crossing right here at negative 1 and up here at 7. So from this graph we can see pretty clearly what my solutions are. I'm going to change my y values. Let's go negative 10 to 10 here, just so it doesn't look so smushed. We want a nice graph here. Now remember, we can also look at the table to find these values. So here we are at negative 1 and 7 as our solutions. So I think it's a good idea when we're working these problems to graph them whenever you can to double check your answers. And then also we can check out what the table is saying as well to verify your solutions. Okay, so here's our graph, and then let's go ahead and find the table as well. So table, we'd go second table, And we're just going to look for solutions here. I see here's a solution at -1, 0, because that's where it crosses the x-axis, is at -1 when y is 0. And I see we have another solution here at 7, 0. So again, solve these by hand, make sure you remember your cases, but also remember that you can check your work by using the table. Okay, now not all the time will our answers be nice integer values like they have been for our example here, but remember you can get your decimal values, and then from these decimal values you can get your approximations to check your solutions. So this is x equal -1, that's shown right here, and this is x equals 7, which is the solution shown right here. So these verify that my solution is x equal -1 and x equals 7. Therefore x equal -1, 7. Now when you list your solutions, you usually only need to worry about the -1, 7 in the parentheses or in the curly braces, because that's what they're talking about here for solutions. You don't need the x equal because they've already asked you to solve for x. So that's an example of solving in an absolute value equation. Now let's look at another example. Let's look at the absolute value. We use an equation again of, let's say, 2x plus 1 equals -3. So this is saying the absolute value of what number is equal to a -3. Well, you can tell when we were working before, when I take an absolute value of a number, I always get a positive solution. So there's no solution here. There's no such number I can plug in that will make this true. So it's no solution, and it's no solution because of that negative sign on the right-hand side. Now sometimes you'll need to simplify first, and that won't stay negative. For instance, if I had, let's say, a -10 over here and added it across, it would become positive. So you always have to make sure you isolate the absolute value first, and then from there, after you isolate the absolute value, if I still have the negative sign on the right, then there's no solution. So to graph this, to check to see what's going on, I would add the 3 across to set equal to 0. So let's go ahead and graph this to see what we have. So we have y equal absolute value of 2x, what was it again, plus 1. And that's what's in my absolute value sign. And then we had to add the 3 across. And let's go ahead and graph this. Now when we graph this, we can see that it's not ever crossing the x-axis. It never touches the x-axis, and if it doesn't cross the x-axis, it cannot have a solution. So if you're stuck on some of these, a quick little graph shows you right away it never crosses the x-axis, so there's no solution. Now if you try and write out your cases, you can write out your cases, nothing's going to stop you from doing that, and you're going to get some answers, but if you plug those answers in, they won't work. So you have to be able to check and make sure they make sense. So it's always a good idea to plug these in. Now we talked about using these and simplifying an expression or isolating the absolute value before you solve, and again, you should get in that habit. Isolate first. For instance, we could have 3 times the absolute value of 7 minus 7/4 x, close the absolute value, plus 9 equals 30. So what we're looking at here then is isolate the absolute value first. So isolate the absolute value. You cannot take the 3 and distribute it. It's not like a set of parentheses. I have to keep the 3 on the outside. So to get started, we'd subtract 9 from both sides. So I'll have 3 absolute value of 7 minus 7/4 x equals 9 minus 9 cancel. 30 minus 9 is 21. And then along the line, going in the same direction of isolating the absolute value, we divide both sides through by 3. 7 minus 7/4 x, absolute value equals 7. 21 divided by 3 is 7. And now we write out our cases. Remember, for absolute value, you always have cases. We'll have 7 minus 7/4 x equals 7, and 7 minus 7/4 x equal -7. So I have the positive case and the negative case. So we'd subtract 7 from both sides. -7/4 x equals 0. We'd multiply both sides through by -4/7. Whatever you do to one side, you have to do to the other to maintain that balance. Now over here on the left-hand side, everything cancels, and I'm left with x equals 0. And then over here on the right-hand side, I'll subtract 7 from both sides. I'll have a -7/4 x equals -14. Multiply both sides through by a -4/7. Whatever you do to one side, you do to the other. Everything cancels except for the x. A negative times a negative is a positive. 7 goes into 14 twice. 2 times 4 is 8. And remember, the two negatives became a positive. So I have two solutions here, x equals 0 and x equals 8. Now, you should always check these either by graphing or by plugging them back in. So for this example, let's go ahead and graph to check our answer. So under y equal, let's make sure we clear that out. We'll have 3 absolute value, which is under math. Second option over here to the right, 7 minus 7/4 x. Okay, that's the end of my absolute value, so you'd close your parentheses there. Now mine was a +9, and I have to subtract over the 30 that was on the right-hand side. Now I think it's a good idea to start at the original instead of my simplified version in case I made any mistakes. Looks like we'll have to change our minimum y value so we can see what's going on here. Those absolute value graphs always come to that sharp point either at the top or bottom. So y min, let's go -25. So it should cross at 0, and then we'll cross over here again at our other solution. So this is a good way to check your answers. And again, so far these have all been integer values, so they've been easy to just kind of glance at the graph. But remember, if they're not integer values, you can still check your work. You might come up with a fractional value and then double check your solutions by finding the decimal equivalent by using your, on your calculator, you would go under second calc in your graphing mode and then choose the option to find your zeros. Okay, so we can see from looking at our picture we have a solution here at x equals 0 where it's crossing the x-axis, and if we count our tick marks over, we're going by units of 1. We also have x equal 8, so this verifies that solution. So again, do your handwork, make sure that you write out your two different cases, and then once you have your two different cases written and you have a solution, plug them back in and check, or you can also graph and come up with decimal equivalents. Now so far everything that we've looked at has had just an absolute value on one side. We could also work problems that have an absolute value on both sides. For instance, we could have the absolute value of 6x minus 19 equals the absolute value of 10x plus 15. Well, we write out our cases as before. So again, we can't isolate the absolute value because we have two of them. So let's just go ahead and use this as is and write out our two cases. Now here we have to be careful about parentheses. So I have 6x minus 19 equals 10x plus 15. That's one case. And then our second case is 6x minus 19 equals the negative, and in parentheses we need the 10x plus 15. So I'm negating the entire right-hand side. Now the important thing to remember here is that the negative has to distribute through. Let's go ahead and work on the left-hand side first. I'm going to get my variables on the left. So 6x minus 10x is a negative 4x. Get my constants on the right, so I'll add the 19 across. So we have 15 plus 9, 34, divide both sides through by a negative 4. And of course we have to reduce the fraction, so this would be a negative 17 over 2. So that's my first solution, I think. We'll double check this, of course, by graphing. And then over here, let's work to find our second solution. The negative sign has to distribute through, So I have 6x minus 19 equals negative 10x minus 15, and then I'll do the same thing. I'll move my variables to the left, and then I'll move my constants to the right. Divide both sides through by 16 and reduce the fraction, and I get 1/4 here for my answer. So I think my answers are negative 17 halves and 1/4. Now, as a decimal equivalent, negative 17 halves would be a negative 8.5 or negative 8.5. Let's go ahead and graph this one. And remember, when we graph this, we need to make sure that it's set equal to 0. So what we'll actually be graphing is the absolute value of 6x minus 19 minus the absolute value of 10x plus 15 equals 0, or equals y, because it has to be set equal to 0. So let's go ahead and graph this and see what we have. So we have our y equal. So we have absolute value, math, and then we arrow over to the right under the number menu item and choose absolute value, 6x minus 19. I have to make sure we're outside that absolute value, and we subtract off the absolute value. It's under math, arrow over to number, 10x plus 15. Let's go ahead and graph this. Okay, looks like we're going to have to go up a little higher on the y-axis to see what's going on here. We can see that it's crossing between 0 and 1, so that value of 1/4 would make sense here. And then over here on the left, 1, 2, 3, 4, 5, 6, 7, 8. This is between negative 8 and negative 9, so the value of negative 8.5 would make sense. Let's just go ahead and go up higher on that y-axis. So y max, let's go up to 25. Might not be high enough, I might have to adjust it. Yeah, we'll have to adjust it just a little bit higher. So that y max, let's go up to 40 just to make sure we have it cleared. Now if you notice, this isn't looking like this symmetric absolute value that we're used to seeing, and that's because there's an absolute value on either side of the equation. So we're not getting that nice sharp symmetric shape that we're used to seeing. Okay, so we can see from the graph that our solutions look reasonable, but it doesn't verify that our solutions are correct. Our table is not going to give us this value either, because our table gives us integer values. So let's go over here to second table. And again, when we see this switch from positive to negative in the y-axis, that tells us it crossed somewhere between 0 and 1, but not where. So if we want to find the exact value, we have to go to second calc, and we choose 0. It's the second option here, because I want to know where is the 0 of the function. Now where this is flashing, it says I want to be to the left of where I think the 0 is. Well, I want to find this 0 first, that I think is negative 7.5, or sorry, negative 8.5. So I'm to the left, and then it says to the right. Now I know I'm to the right of where it crosses. And now my option is the guess, and I can arrow down to the guess, or I can just hit enter again. And you can see right here it says the 0 is negative 8.5. So that verifies that that's my solution there. Now I can do the same thing for the right endpoint. What you want to keep in mind is it's worth the time to check these. Don't just guess at an answer, especially on a quiz when you might have to redo the entire quiz if you get one wrong. But get used to these, because that way on a test then you'll also see the correct solution. Okay, let's go ahead and do the same thing again. Second calc. Choose the second option to find the 0 of our function. Now if I want to, instead of arrowing over, I know the 0 is to the left, so I can just type in a 0. And I know 1 is to the right, so I can just type in a 1, and you see how it frames our point right here. And then you can just arrow over to where you think it crosses. And it doesn't have to be exact, it's just a guess. And I can see here that it's crossing at 0.25. Well, 0.25 is the decimal equivalent to 1/4. So I've verified both of my solutions. So again, it's worth the time that it takes to verify these, because on a test or a quiz you don't get a second chance at those. you have to redo the entire quiz, or on a test you just get it wrong. So it's worth taking that time. So let's see how this looks then. Here's my 0 at negative 8.5. So this is the solution, the root, the 0, negative 8.5. And this is the solution, or root, or 0, of x equal 1/4. Now in my math lab, they'll want the fractional form. They don't want the mixed number. They want the fraction, negative 17 halves and 1/4. They don't want the decimals either. So these are some examples of solving absolute value inequalities, and you can see how important that it is to double check your work. Now another type that we'll see is an absolute value that involves a quadratic. So for instance, we could have the absolute value of x squared plus 5x minus 12 equals 12. Okay? So again, what we want to focus on here are cases. So for our cases, I'll have x squared plus 5x minus 12 equals 12 for one case. And then for my second case, I'll have x squared plus 5x minus 12 equals negative 12. Now these are just nice quadratic equations now that we've solved before. What I need to do, of course, is get them set equal to 0 and kind of work from there. So I will subtract 12 from both sides. So I get the set equal to 0, and I have x squared plus 5x minus 24 equals 0. Now our hope is that these factor nicely. This does factor. I think we have plus 8 and a minus 3. So for this case, I have x plus 8 equals 0, or x minus 3 equals 0. I'll subtract the 8 from both sides. X equal negative 8. Here I'll add the 3 to both sides. And I get x equal 3 for this case. Now over here on the right-hand case, I'll add 12 across, plus 12 plus 12. So I get x squared plus 5x. These cancel over here equals 0. Now I can just go ahead and factor out an x, use the greatest common factor, and I get x equals 0, or x plus 5 equals 0. Here we'll have to subtract 5 from both sides, and I get x equal negative 5. So my four solutions, negative 8, 3, 0, and negative 5. Now we can plug all of these back into the original to double check them. I'm going to go ahead and graph this to double check my answers. So under y equal, we go ahead and clear out what we have. Absolute values under math, arrow over to the number menu. Absolute value is the first option. And this was x squared plus 5x minus 12. That's what's in parentheses. Now I need to remember to subtract over that 12. Now this should cross 4 times. There's 1, 2, 3, 4. Now these cross at all integer values, so I don't have to double check anything, but if I wanted to double check, I could do second calc and then use the 0 function. But from here it looks like all of our solutions are verified with what we found by hand. Now remember, when I'm graphing this, I'm graphing the option of the absolute value of x squared plus 5x minus 12, close the absolute value, subtract the 12, and make sure it's set equal to 0. So here's my 4 solutions. So here's x equal 3, x equals 0, x equal negative 5, and x equal negative 8. So you can see that each of my 4 solutions up here have been verified. So therefore my solution is x equal negative 8, negative 5, 0, and 3. And you should always try and put those in order from the smallest to the largest number. So these are the different types of absolute value equations that you'll be solving. We'll also be working with absolute value inequalities. So let's go ahead and talk about inequalities next. Inequalities are with the less than, the greater than, the less than or equal to, and the greater than or equal to. And what we need to remember here is cases. Again, we have cases. So the first case that we want to look at is if we have something like the absolute value of u is greater than c. Now this u could be anything. It could be an algebraic expression, it could be a quadratic, but what's important is you isolate the absolute value, you have an inequality, and then you set up your cases. So the cases here would be that, first of all, u is greater than c, okay, and then the second is or u is less than negative c. Well, what happened, we just dropped the absolute values for the one case, and then for the second case we flipped the sign and negated the right hand side. Now what I do is I graph both of these options when I get done solving, and then I look to see where our solution is. Now if this was an equal sign, the only thing that would change here is there'd be equal signs for each of these. Okay, second option, that's the greater than option. Let's look at the less than option. The absolute value of u is less than c. This case is really nice because what basically we do is we negate the c, kind of flip it over this way, and then we run through all the possibilities up to the positive c. Notice we leave the signs less than, and then I solve here. Now this is actually two cases. It doesn't look like there's two cases, but what we have here is u less than c. So that's this piece. That's just dropping the absolute value sign. But this time we have an and. Notice that over here we had an or, but now we have an and. And then I flip the sign and negate the right hand side. So flip the sign to greater than and then negate the c to get a negative c. So this is the shortcut, kind of the easier way to write it. But sometimes if we get in a pickle and there's a negative variable like a negative x inside here, it's actually easier to write out the two cases. So keeping these in mind, let's go ahead and write out the different cases for some of these problems. Let's look at the absolute value of x minus 7 is less than 2. Okay, well this is the less than case. So the less than case, I always look at this and it kind of points to the left. And so that's telling me to take the c and negate it to the left. So I take the negative 2 less than x minus 7 less than 2. And then to solve, we'd add 7 to each part. Negative 2 plus 7 is 5, less than x less than 9. So this means 5 is between x and 9. So that's my solution. Now if we had to write this out, a lot of times we'll put this in interval notation. Remember, this is solution builder notation, I believe they call it, or set builder notation. So this is set builder. And then we'll have interval notation. This notation means between. When I have the two less than signs and my numbers run small to large, this means between. So this runs between 5 and 9. So this is interval notation. Now on your homework, sometimes it just asks you to rewrite without the absolute values. So if you rewrite without the absolute values, you would stop here. If they ask you to solve, then you would go further to either set builder or interval notation, depending on what they're asking for. So you kind of have to read the directions carefully. Let's go ahead and do a very similar problem. Let's look at the absolute value of x minus 7 is greater than 2. And remember, cases. We have cases here. This is the greater than, so I need to write out my two distinct cases. I have x minus 7 is greater than 2, just drop the absolute values. And then the or, x minus 7 is less than negative 2, so flip the sign and negate it. So we'll add 7 across. X is greater than 9, or add the 7 across. And I have x is less than 7 minus 2 is 5. So x is greater than 9, or x is less than 5. So remember, if they're asking you to write out the cases, these are the cases. If they're asking you to solve, this is what we're looking at. So this is our set builder. If they want us to use interval notation, greater than 9 would be 9 to infinity. I use parentheses at the 9 because I don't have an equal. Union is my or. X less than 5 would be negative infinity to 5. And in fact, I really don't like how I have that written. Let's put this on a number line first. So here's 5, here's 0. Whoops, there's not 0 there. So here's 5, and here's 9. So here's greater than 9, parenthesis to infinity. here's less than 5. So I should have written this negative infinity to 5, union 9 to infinity, because we want to go small to large, just like we read numbers. So that's why it's not a good idea just to go in the order here, but make sure they go in order from small to large. So read the directions, because they might just want the cases, or they might want you to actually solve. When you're solving an inequality, you have to follow the same rules as before. You need to isolate the absolute value. So the first thing you should do is isolate the absolute value, and then once the absolute value is isolated, then what you can do is you can go through and actually solve some of these inequalities. Let's go ahead and look at an example with a fraction. So this is the absolute value of 2x minus 1 all over 5 greater than or equal to 9. Well, the absolute value is already isolated. If you want to, you could try and pull that 5 out by multiplying both sides through, but I think it's easier just to write out your cases. So our first case, this is greater than 2x minus 1 over 5 greater than or equal to 9. Now greater than has an R in it, so that helps you remember that greater than, I use the or case because or also has an R in it. And then in my other case would be 2x minus 1 over 5 is less than or equal to a negative 9. So I flip the sign and then negate it. Okay, solving both here, I'd multiply both sides through by 5. Whatever you do to one side, you do to the other. So I have 2x minus 1 is greater than or equal to 45. Add the 1 across. 45 plus 1 is 46. Divide both sides through by 2, and I get x is greater than or equal to 23. Second case, I'm going to multiply both sides through by 5 as well. Whatever you do to one side, you do to the other. 5's cancel. 2x minus 1 is less than or equal to a negative 45. Add the 1. Negative 45 plus 1 is a negative 44. Divide both sides through by 2. X is less than or equal to a negative 22. Now remember, this is an OR. And remember the rate, I remember that, is our original problem was greater than, and greater than has an R, so I remember that's the OR case. Let's go ahead and put these on a number line, and then we'll go ahead and put our solution in interval notation. So here's a negative 22, here's a 0, and a 23. This is greater than or equal to a negative 23, so that's a bracket because I have equality. Greater than is to the right. Negative 22, I have an equal sign, so I use a bracket, and I'm using less than. So when I write these out, remember it's an OR, it's not what they have in common, it's what's covered. This would look like negative infinity to negative 22, or we're going to use our bracket, not a parenthesis, 23 to infinity. And there's our solution. You have to be careful about how you write these. You want to go in order from smallest to largest. That's why we start at negative infinity and go off toward positive infinity. And you just have to be careful when you're setting up your cases. And once you get your cases set up, these are usually pretty straightforward problems. Now you might say, well, how do I work with these in terms of graphing? Well, when we graph these, every problem that we look at for graphing, I can really only use an equal sign, so I kind of have to understand what this is looking at for graphing. So let's go back up here and look at the graph for each one of these. So the graph for this one would be the absolute value of x minus 7 minus 2 is less than 0. Now I can't put in the less than 0 part, so I'll only be graphing this. So the absolute value of x minus 7, and then subtract 2 from outside the absolute value. So absolute value, math, arrow over to number, absolute value of x minus 7, and I think here, what did we have? Minus 2. Remember, that's outside the absolute value, and go ahead and graph this. Might need to change my axes a little bit. So let's go to window. I'm going to go negative 10 to 10 on my y. It's not going to be exactly centered because most of my solutions appear to be over here on the right. 1, 2, 3, 4, 5. So it's crossing at 5 and a 9. So let's go ahead and pop this graph in. So again, I can't really do anything about the less than or equal to, but I can graph the equal case and then talk about what the rest of it means. Okay, so basically this is the graph of the absolute value of x minus 7 minus 2. And I want to know, where is this less than 0? Well, these seem to be our important points right here and here. So this is 5 and 9. Well, less than 0 means below the x-axis. Because these are where my y values are less than 0. And we can see that it's less than 0 all along here. So between 5 and 9 is where that's happening. So the graph doesn't give me the answer, but it gives me a nice picture that can help me find the answer pretty easily just by graphing. Okay, now really this next one for graphing would be the same problem. Negative infinity to 5 and 9 to infinity. So let's go ahead and pop that same graph in. Just shrink it down. But in this case, when we graph it, what I'm looking for is where this will be greater than 0. So I still have those two important points, and they're hollow points because I don't have an equal sign. So here's x equal 5, and here's x equal 9. So when I graph this, I'm looking at the absolute value of x minus 7. Minus 2 is greater than 0. Well, I can see the minus 2 is greater than 0 means I'm above x-axis. And you can see that I'm above the x-axis here and then over here. It's kind of cut off a little bit, but we can see the graph would continue. My x values for this would be from negative infinity to 5 and then start up again from 9 to infinity. And of course I'd have parentheses there. So using that same idea, let's go ahead and graph the absolute value of 2x minus 1 all over 5 is greater than or equal to 9. So the absolute value of 2x minus 1 all over 5 minus 9 is greater than or equal to 0. So that means we're looking for where this graph is above the x-axis because I have the greater than or equal to 0 case. So let's look at y equal. Let's clear this out. So we want absolute value math, option over. And now we have to be careful about this because I need my 2x minus 1 in the numerator, so it has to be in parentheses, and then divided by 5. And then outside of the parentheses, I can do minus 9. So you have to be careful that you get that correct numerator in there. Okay. Now, when I solve this by hand, my solutions where I was crossing were at negative 22 and 23. So I think on my window, my x min and my x max are going to have to change. Let's go from negative 40 to 40, just to make sure we have it covered. Let's hit graph again. Now I see it crossing. So you could count the tick marks, or you could go to the table to find these values to help you solve. But we're looking to see where this is greater than or equal to 0. So we're looking at the part of the graph that is going to be greater than or equal to 0. That's above the x-axis. Again, this is above the x-axis. We're above the x-axis from whatever this point is to infinity, and from whatever this point is to negative infinity. So that would be negative infinity to whatever this point is, and we can see from up here it's negative 22, or you could use your table function. You could go under second table and then figure out where it crosses. So this is our negative infinity to negative 22. It's bracketed because I have an equal sign. Union starts up again at 23 and heads off toward infinity. So again, absolute value doesn't just graph very nicely with an inequality, but you can determine what those values are from looking at the graph. Now all of our same rules with working with inequalities hold. There's just a couple quick things I want you to make note of. I'm not going to solve all these, but I want to give you a good start to some of these setups. Now for this problem, I have to isolate first, so I'm going to divide through by a -4. But remember, whenever you multiply or divide across an inequality, I have to flip the sign. So this sign has to flip. -16 divided by -4 is a +4, and then I would just write out my cases. So again, you can go ahead and solve from there, but what I'm looking at here is just getting you started with some that are set up a little bit differently. Now this one, if you notice, the absolute value is on the right hand side, and really we want the absolute value on the left hand side. So we can look at our cases. Now notice this opens toward the absolute value. So now when I flip it, it has to open toward the absolute value still. So this is an equivalent expression. It's just a rewrite to show you what's going on here. So again, you want to keep those in mind when you're solving for some of these. This next case is kind of combining a few tricky things. So we might have 8 less than absolute value of -2x plus 4/5. And then on the outside I have a plus 2/5. So to get started on this one, we'd want to subtract 2/5 from both sides. So 8 minus 2/5 would be 7 3/5, less than the absolute value of -2/5, 2x plus 4/5. And then I want to rewrite this by moving the absolute value over to the other side. Now notice this opens toward the absolute value, so when I flip it, it has to open toward the absolute value as well. We don't want to work with this as a mixed number, so let's go ahead and rewrite this as an improper fraction. 7 times 5 is 35. 35 plus 3 is 38/5. And then from here you would just go ahead and write out your cases. Now you'll have a couple of other options too. Sometimes they'll give you an absolute value equation, and then they'll tell you one other condition. They'll say, and y is greater than 7. Or sorry, let's do less than 7 in this case. So when you write this out, you would write this out as the absolute value of 3x minus 8 is less than 7. So we know what y is. Y is 3x minus 8, so we just plug in y for here and then solve with our cases. So again, talking about those cases is very important. Make sure you always keep in mind the cases. Sometimes you'll be using some terminology like at most 7 or something like at least 3. Well, at most 7 basically means I can be anything up to and including 7. So 4 is at most 7, but 8 is more than 7. So at most 7 would mean less than or equal to 7. At least 3 would be 3 or larger, so this would be the case of greater than or equal to 3. So this is at least 3, at most 7. When you're working through your homeworks and quizzes for this section, I would really encourage you to graph these as often as you can to kind of get an idea about how many solutions that you'll have and what those solutions are in terms of integers or decimals. If they're decimal solutions, make sure you remember that you can check your answers, especially on a quiz or a test. It'll be really important. If you have questions about the lecture, please feel free to bring those to class where we're happy to help you out. You can also stop by during my office hours or the Math Center. Good luck.